All right. So, continuing on through chapter 1 here. Starting with the kickoff. So, what is the difference between solutions, zeros, intercepts, and roots? Well, solutions are when we solve for x. Zeros are when we set equals 0 and solve for x. Intercepts are where we cross the x-axis. And roots are when we square root, cubic root, whatever, factor it all down and get what x equals. So you kind of sense a theme there. They're all really the same thing. It's just different names for the stuff. To get those intercepts, again, we set it equals 0 and we solve. To find the roots, we set it equal to 0 and solve. Solution, set it equal to 0 and solve. 0, set it equal to 0 and solve. All those are when we set it, our equation equal to 0, and we solve for x to find out what x will equal. So, going to be looking at functions, starting here with a relation. A relation is any set of ordered pairs. So the set of all first components of the ordered pairs is called a domain of the relation. All the second components are called the range of the relation. So, looking at this here, this would be a relation. Basically, we have a grouping of ordered pairs. Well, the domain is going to be all the x's, that first component of the ordered pair. So, domain would be the set of 5, 10, 15, 20, 25. Range then is all the second components or the y's. So think of domain is the x, range is the y. So 12.8, 16.2, 18.9, 20.7, and 21.8. Now, we can also represent this with columns and arrows showing it. So let's say we had 1, 2, 3. Over here we could have 2, 4, 6. Well, we can show how that relation ties by drawing arrows to numbers. And they don't always have to go just straight across. It's just linking, okay, hey, this one goes with this one, this one goes with this one, this one goes with this one. It's just showing you, it's more of a visual of how to go together, versus here is more of an analytical, you have the numbers, boom, we see it as an ordered pair of these are paired together. Now, from there, a relation can be put as a function, or classified as a function, I should say. A function is a correspondence from the first set, the domain, to the second set, the range, such that each element in the domain corresponds with exactly one element of the range. So really what it's saying here is we have a set of x's, we have a set of y's, and so we're going to pair every x with one y. So if you think about it, the x's cannot repeat. The y's can, but the x's cannot. So looking at this, 1, 2, 3, 4, the x's don't, even though we have two y's with 6's, each x has its own number. So this first one here would be a function. Second one, well, we have 6 and 6. So 6 could either be 1 or 6 could be 2. And that's where the issue is. So that's why this is a no. Is the x's can't repeat. If we put an x out, there has to be exactly one number that comes back. Now, that number may be shared among x's. So like here, if we put 1 in, we get 6. If we put 2 in, we get 6. Even though 1 and 2 both have 6, they each have their own number. Where here, if we put 6 in, well, we could get 1. Or if we put 6 in, we could get 2. If we have multiple things going with that 1x, that's where the issue lies. So where are these functions? Which this one should be over here, but that's part of blowing up the size of the text. So 1, 2, 3, 4, 5, 6, 5, 8. Oh, we were doing good, but now we have a repeat here, so this will be a no. 1, 2, 3, 4, 6, 5, 8, 5. Again, the second one can repeat, that's fine. But 1, 3, 6, 8, the first ones cannot, so yes, it would be a function. Now, we can also give these as an equation instead of an order pair. For example, y equals negative 0.016x squared plus 0.93x plus 85. So that's another example of what a function could be. Now, why is this a function? Well, we can have x squared, x, whatever, all over here, but it's only a single y is what we need to have. So what it's saying is we can put an x in and we're only going to get one answer out. It's not like we could get multiple answers, and I'll expand on that here in a little bit. But when you're dealing with these, x is your independent variable. So that's the one that you're going to be putting in. We're going to put in certain x's, so we're going to pick x's to sub in to the equation, which is your domain. It's the input, what we're putting into the equation. Y now is going to be the dependent variable. So it depends on which x we put in that it's assigned to from that range. I think it's the output. So we put in this x. What we get out of the function is your y, your domain, your range, sorry. Domain, input, range, output. So looking at these, this first one's going to be a yes because we have that single y. All we got to do is subtract the x squared over, and we're in that y equals form. So we only want a single y here. This one is y squared. That's going to cause problems because when you solve for this, you would then square root it. Well, remember, when we square root, we get plus or minus the square root of 4 minus x squared. So that plus or minus means we have multiple options for that one x. We put that x in, we could get a positive, we could get a negative. If we get multiple things from that one x, that's bad. We want, when we put an x in, we get a single answer. Okay? Now, a lot of times we'll use function notation, which is that f of x instead of y equals. So example would be like f of x equals x plus 2 instead of having y equals x plus 2. Now, whatever's in these parentheses is whatever x is going to equal. So like f of 10 in this case would be x equals 10. So working with these, and it appears I got something cut off. Oh, we want f of 2 first. That's right, my bad. I want to try a couple things. So f of 2 means we're going to do 2 squared plus 3 times 2 plus 5. Well, 2 squared would be 4. 3 times 2 would be a plus 6, and then plus 5 would equal 15. So just like if I did f of negative 1, again, negative 1 goes in for the x. And what we get out is our solution, our y. So negative 1 squared is still 1. 3 times negative 1 would be a minus 3. And then plus 5. Well, 1 and 5 is 6. Minus 3 gives us 3. So that's what's going on here. Now, keep in mind, if we did f of x plus 3, every x gets x plus 3. So x squared becomes x plus 3 squared. 3x becomes 3x plus 3. Now, this here would have to be FOILed. So that's really x plus 3, x plus 3. So x squared plus 3x, 3x, 6x plus 9. Here, this would have to be distributed in. So plus 3x plus 9 plus 5. So that's where the x squared, 6x, 3x makes 9x, 9 and 9 is 18, plus another 5 is 23. So that's where they're getting that all. Now, when it comes to graphing functions, you want to use an XY chart and then draw that line. So XY chart, again, is when we do X, Y, and then we pick, say, 3 X's. Now, typically, these are going to be your better 3 to use. They're the smallest numbers you can use in doing these. And then whatever you get else out, then makes your order pair. So that's where you can plot those points and then draw your line. Now, keep in mind, shape here is going to depend on the exponents of the variables. So that's where we talked, like x squared would be a parabola. X to the third would be that S-shaped looking thing. So that's all going to determine what type of shape the graph will be. Now, vertical line test will prove if it is a function. Now that graph can only touch it once. So like as I come through here, it can only touch my pen once as I go through to make it a function. If I had something where it did something like that, well, when I get to here, now I'm touching 3 times. This would not be a function. These over here only touch it once all the way across, so those would be functions. Now, when you're looking at a graph, again, like I said, shape will determine the exponent of the variable. So if it is in a parabola shape, I know it's going to be an even exponent. If it's an S-looking shape, I know it's going to be an odd exponent. Generally, it's going to be either x squared or x cubed there. But that'll tell me what sort of exponent goes with that. We can find the domain values of the graph by looking at it, seeing what x's are going to be involved. We can also do that with the y's. So 2 different notations for domain and range. Interval notations where we use the brackets. Remember, bracket means equal to. If it's parentheses, it just be less than. And it's always from this one to this one. So the least to the greatest. Set builders, the other way, we're writing it with a set and an x such that using inequalities. So, like for example, if I have, say, this graph. Well, looking at this tells me that, hey, it's going to be an even, most likely x squared. As far as domain goes, well, the domain, as we're sloping out, we're still sloping out each direction as we work up. So domain, in this case, would be negative infinity to infinity. So in other words, all reals. Because it's working out to the right, out to the left, it's going to cover all of them eventually. Now, as far as range goes, well, the range would only go from here up because we don't go any further down with our graph. So that's where we would do the bracket 0 to infinity. Because we're not going any lower than 0, we're not going any lower than that line, but yet we're going to go up forever. We have the arrows pointing up. Okay. So, x-intercept, zeros, root solutions, all where the line crosses the x-axis. Now, with this, you can have multiple times where we cross that x-intercept at x-axis. We could have as many times of those as we want. However, for this to be a function, only one time can we cross the y-intercept. If we have 2 y-intercepts, it's not going to be a function because, again, that x, so technically when x is 0, you're going to get 2 different things out, and that's the issue. We only want one thing out of that equation. And that's it. That's this lesson. So, remember, you can always pause or rewind if you need to catch something, need time to write stuff down. You can pan me, email me, leave a message on Google Classroom. Any of that works. If you have any questions, comments, concerns. Otherwise, we'll talk to you later.